What are the advantages of using this parametric software? One of them is alignment changes, right? What is the regular workflow when we work with applications like OpenBridge Design? We reference the geometry. Uh, Information coming from our Bentley roadway application, Open Roads, is referenced. Of course, we're going to review what the reference file is. We reference that into our bridge design file, or we can import that information from other solutions. Then this alignment will become the working alignment for the active bridge, alignment and profile. And then if any roadway geometry changes in the application, for example, open roads, as we reference that information into OpenBridge, so then the changes are reflected immediately. And if there is a bridge placed along that geometry, the bridge will also react immediately as well. Here, to illustrate this concept, right? So this is open roads. So the roadway engineer is using open roads for its design, alignment, and profile. We are into our open bridge application and with the bridge fully modeled. But then that information, again, we're back in open roads, is being referenced. Uh, our bridge is being referenced into open roads, not only in plan view, but also the highway engineer has the ability to quote unquote cut a profile along this vertical alignment and see where the bridge is exactly located. Remember, we're using real geometry, so the bridge is going to show up where it's supposed to be, right? Along the alignment and along the profile. So that operation is called a 3D cut in open roads. So that is the location of our bridge. But now the roadway engineer, maybe because of drainage purposes, or clearance, or passing distance, he makes a modification in his profile. So he designs that, and of course, our bridge will be at this time misaligned, right? It will not be following the the profile. So the profile is being elevated, and of course, there is a discrepancy with the bridge. So now we need to come back to our bridge application. So the bridge engineer will open his bridge application, or if it's already open, he will see in his computer in the reference file option that there is a little pencil here, meaning that the geometry or something in this file, in the geometry file owned by a roadway engineer has changed. Something has changed, so he just needs to reload the information, not transfer, not export, just reload it, update it. Uh, since the alignment and profile has changed and I am in the bridge application, my bridge will react to it. In this case, the bridge will just go up. So basically lengthening the height of the piers, keeping its information relative to the ground. So now more design work is to be done, right? So bridge is updated. So then the roadway engineers could continue doing their work, updating the rest of the roadway as well, right? So as I said, this is the new level of collaboration, immediate collaboration. Not only that, but then sometimes we need to update the bridge elements itself, depending on we want maybe a different kind of a structure. We need to update, want a certain elevation. We want different geometry that we have placed. So in this case, for example, on this footing, I may want to update whatever we place with the bridge template that we use. So we select the element and go to the template that we use. And I want to change that particular one, maybe to a different configuration, maybe use 3 columns instead of 2, or maybe not use isolated footings, but actually combined footing. So there is no need to remodel, just via a template file. I can change anything that I need. right? Here, for example, I don't want rectangular columns. I want cylindrical, different diameter, different footing configuration, right? Combined footing. If I do that, I need to redo the pile configuration. So I may want to do that as well. Or maybe I want no piles. So all that options are available via dialog box without any extra programming needed, just modifying the templates that I'm using. And if the template is good enough for this project, I may want to reuse it for another project. So I can save that configuration that I just did to the company library, right? Not just the project, but the whole company. So here, for example, since I switch from isolated to combined, I need to redo the pile configuration. Um, Specify distance, and so we'll just generate that. Uh, if it looks good, so then I just save it to my library or just place it and make it part of my model as well. At that time, just to remind you, the library, when we place that element, the element is disconnected from the library, so it just became its own element. So that's why we can transfer this bridge to another computer, to another user, and there is no need to transfer the libraries with it because they are part now of the particular element. So here we're adding a crash wall, for example, and then that's it. But then there is not much of an update there because we need now to adjust it according to the ground. So we need to establish a certain distance below the ground, and I can do that. What ground? Well, the ground that I selected at the beginning of the bridge, the terrain, right? And now I have my footing placed at a distance below the ground that I specify, and still being able to change dimensions or update elements. So, for example, I don't want a crash wall anymore, and it's just updated. Right now, what's the other option? We mentioned as well the ability to do clash detection, utility conflicts. So that is when the collaboration among disciplines become extremely important. Now, how this clash detection is done? Well, fairly simple. It could be visual, right? As you can see, I can have this red line or red 3D element that represents a water line given to me and just place the bridge. Obviously, there is a conflict with the foundation of the bridge right there. So I just did a very quick clash detection, but there's so maybe hidden ones where I need to calculate the distance more precisely. So I use the clash detection tool present into the platform, right? So invoke that tool and I will create what is called a specific job. Why it's a job? Because it could be safe. As I'm designing, these jobs could be run every time I design, every time some new information comes to light. So I don't need to do the setup that I'm going to do every time. I just save it as a job, right? So what I'm going to do is I'm going to tell the software to give me any conflicts, hard conflicts or conflicts with a certain envelope or a clearance between two elements. And this list that you see here, it's level symbology, microstation levels. So I say levels, check the level piles, becomes highlighted in red. These are all the elements that are into that level against the level in which this utility is. It doesn't need to be on the same file. This is on a reference file, but still the level exists. So it's on the utility level. So saying that, I just say process, it will tell me where this is a hard conflict. As you can see, it's very obvious visually, right? But then I can also give me a distance around that element. So I can see if there is a conflict on excavation, for example, and it has found the clashes, right? We can specify in these columns, not only to specify the clash itself, but also the clearance, right? Or the distance between these two elements. So I can also specify envelopes, maybe for excavation purposes, right? But that's basically that is the clash detection tool there. So usually we think of clash detection as clearance verification, but it's more than that. It could be any kind of clearance, so not only vertical but horizontal, right? And that will help us a lot when we are designing. Okay. Now another option to create 3D models is the ability to generate plans production. Yes, one of the tenets of BIM is that the 3D model is the one that has all the information, and it is from the 3D model that we can extract 2D plans. So if we cut a section, a perpendicular view of the bridge, well, we have a typical section. If we look the bridge from the top, we got a plan view. So that's what it is. That's the idea, that from the 3D model, I should be able to generate 2D drawings. And these drawings remain connected. So any changes on the 3D model through the Bentley's reference file technology, it will update automatically the plans, right? And they are specific for bridge. So as part of the tools of OpenBridge is the ability to generate, for example, a dynamic section. So setting up a cut along the alignment, we can just generate what is called a drawing and a sheet. Of course, we're going to explain this in greater detail later, but this is how this tool is being used. So now I have a cut along this pier, along this abutment. This is what I see in 3D. It's all fully modeled. And then I got a view of that. Now, also we have specific tools that cut a substructure sheet or as well a typical section sheet. So we specify what element we need to cut, not as dynamic section, we specify a station, we just specify the structure here, and we'll automatically build up what we call a drawing and a sheet. Right? We can adjust the scale, we can adjust the sheet size, right? It's all predefined if you wish, right? As well as the annotation scale, so a lot of options there. And when we hit OK, it's going to build up that drawing and that specific sheet and place it according to the file. So all the information, this could be automated and the dimensioning is automated as well. So, and that is for the generation of substructure sheets. So we can keep going and generate more options. The frame, right? So it's part of the library. You can customize the library and do it. And I want you to take a look at the dimensions. So now the sheet is created, right? But then it's still connected to the 3D model, right? So let's set up some views here so we can see the 3D model and the actual sheet itself. And what we're going to do is take a look at the height of the cap here. And using OpenBridge commands, I'm going to change, right, the height of the cap. So changing that, and I just want to see that these 5 feet become a different dimension just because I changed it on the 3D model. So there is always a connectivity between the 3D model and the final plans. You know, one more time, emphasizing that all the information should be on the 3D model. The latest information should be on the 3D model, and the plans are just a reflection to it. Right? And the same when we're generating 3D models. Now, sometimes this 3D model or these sheets need to be adjusted, and that's why we're going to use reference file commands to adjust for that. Right? These also could be highly customized, right? As we create, for example, plan and profile drawings. So using present techniques in both softwares, OpenRoads or OpenBridge, we can generate a plan view, a plan and profile view for our bridge. So these tools are also present in OpenRoads. Again, this is no new tool for plans production. It's the same tool that maybe you already know how to use. So it's all across the same platform. So OpenRoads, OpenBridge, OpenTunnel, they use the same drawing production method. So we can do all of that. We can also specify what views to extract, the geometry we want to extract. So it becomes kind of a repetitive process every time we need to create our plan view elevation of a bridge. All these scales and pull down menus that you see are predefined by the workspace. We're going to learn later what the workspace is, right? But it's all could be predefined. So the user just need to just run the tool to not worry about what setup needs to be done for a specific bridge that we may need to do, right? Even the annotation, how we do it on the profile, the grade that we place, the spacing, the text sizes, all of that is predefined. So when we run this tool, well, we have, for example, here our plan elevation view of that particular bridge. Right? And again, it's all connected to the 3D model.